So this week we are going to be learning about statistics and we're going to be learning to interpret different types of graph. Today we're starting with line graphs, which basically do exactly what they say on the tin. It's a series of data points and there is a line drawn with them or through them to show the information in line form. So if you have a look at the information that's contained on here, we've got a series of small dots, which is the individual data points, but then a dotted line has been used to join up so you can actually see the flow of the data as it's coming in. Now, in this particular question, you've been asked to look at what is the same and what is different about the two graphs. Now, essentially, they are the same graph. They're showing you the same information. You can see that the flow of the lines is exactly the same, and you can see the data points is exactly the same. But if we're having a look at them, I would say if this is graph A and that is graph B, graph A is easier to interpret because it's got far more information on it. If we're looking on here, we've got lots more time points on here than we have on the second graph, on graph B. And up the side on the temperature, again, we've got lots more data points on there. Now, graph B is a great way of showing lots and lots of complex data because sometimes there is too much information on at one time for you to actually be able to interpret it carefully. But graph A has all of the data points on it that you need, and within the axes it has the information that you need. Now, for those of you who can't remember, when we're thinking about axes, this bottom one is the x-axis and the one on the side is the y-axis. The way I remember it is y has a long up and down tail on it, so that it's on the side that goes up and down, and the x is in the word exit, and you go along to get out of the exit. So it's an easy way of just remembering which one is the x and which one is the y-axis. Okay, so this graph is actually showing two pieces of information. So it's a really useful way of showing it on a line graph that you can put two sets of data together so you can compare them easily. So if we're looking at this one, the red line is Monday and the blue line is Tuesday. So there's a lot of information contained on here, but it actually shows us the way that the data can be compared and contrasted. So at what times of the day was the same amount of water consumed on Monday and Tuesday? So you're looking for a point at which actually they crossed. So if we're looking here, we have a point here where it crossed, here where it crossed, here where it crossed, and here where it crossed. Now, the key point to remember with this one, actually, that is the only one where it has a clear data point. The other one is actually where the lines that have been used to join up the data have crossed over. So they can be counted, but actually the clear one here is 1 p.m. So the next question, was more water consumed at 2 p.m. on Monday or Tuesday morning? How much more? So let's have a little look now. I'm going to get rid of all my other little squiggles on here just to make it a little bit easier for you to read. So we have to go to 2 p.m. Well, it's not written on here. But if we're looking at this closely, we've got 1 p.m., we've got 3 p.m. So 2 p.m. must be in here. So this must be 2 p.m. So let's have a look. So on Tuesday, how much was used? It was 500 because we're actually taking the line sideways and it shows us 500 millilitres. On Monday, it was static at 750. So the answer to that question, just by reading off that data, it was actually Monday and it was 250 because it was 750 on Monday. Take away the 500 on Tuesday, which means the difference, which is what we're looking for, how much more, is 250 millilitres. Right, so Eva has created a graph to track the growth of a plant in her house. Eva's recorded the following facts about the graph. Now, we need to look at the data first. So along the bottom, we've got 1st, 3rd, 5th, 7th, 9th, 11th, 13th, and so on. And its dates. Now, obviously, we don't jump 1st, 3rd. We go 1st, 2nd, 3rd. So we've got to look at the gaps in between as well. So if we're thinking about this type of graph, actually, that would be the second. So you need to be aware that that's actually there when you're working with the data. On the left-hand side, on the y-axis, we've got the height in centimetres. So it's how high the plant has actually grown over time. So on the 9th of July, the plant was about 9 centimetres tall. Is that true? So let's have a look. So we're looking on the 9th of July. There's the 9th. Now we don't have a data point, but at the point at which it actually crossed, let's cross over, oops, wiggly line, it's not far off true. It might be slightly below 9 centimetres tall, but that's not too bad. Now, obviously, when you're doing it at home on your own, you hopefully would use a ruler or the edge of a book or something that has a straight line rather than me, where my line was very wobbly there. So between the 11th and the 19th of July, the plant grew about 5 centimetres. So let's have a little look. So between the 11th and the 19th, so those are the 2 dates we're looking at, the plant grew about 5 centimetres. So we need to go into this and find out how much the plant grew. Well, on the 11th, the plant was 10 centimetres. On the 19th, the plant was 15 centimetres. So what's the difference between the two? True enough, it is, oops, not sure what that was supposed to be, 5 centimetres taller. So that one is correct. At the end of the month, the plant was twice as tall as it had been on the 13th. So again, I'm just going to rub some of these out just so I'm not confusing with you with all my lines that I've drawn on it. So at the end of the month, the plant was twice as tall as it had been on the 13th. So there's the end of the month. That's the final data we're looking at. There's the 13th. Now, 13th doesn't actually have a data point, but we can see quite clearly that it was at 10 centimetres. So on the 13th, it was 10 centimetres tall. What was it on the 31st? So let's follow it through. Now, again, we don't have grid lines on here, but I'm going to be as accurate as I can. So it's roughly halfway between 25 and 30. So that would be roughly 27.5 centimetres. Now, it says at the end of the month, the plant was twice as tall as it had been on the 13th. Well, it was 10 centimetres on the 13th. So 10 times 2 gives you 20. So I would say that's incorrect because it's more than twice. It's nearly 3 times. So you've got to look at it accurately and be very, very precise in your answers. It says, can you spot and correct Eva's mistakes? Well, we've gone through all of those. So actually, Eva did make quite a few mistakes, but she did actually put some correct information down as well. Final kind of question that you are likely to come across is creating stories about graphs. Now, if you look at each of these individual graphs, they don't have very much information on it at all. So you're asked to interpret what it could represent. So, for example, this one may be, I was in my car, I was accelerating along the road, so I was gradually getting faster, and when I get to the speed limit of the road, say 30 miles an hour, I stayed at that speed for a certain period of time until maybe I came to a junction, and I put the brakes on, and I had to come to a complete stop at this point here. So it's showing going from stationary, travelling at a certain speed, and then eventually stopping. Now, this one, you could take a similar idea with this one. You could think about money. So maybe you had no money and you opened a savings account. Then on your birthday, you put your birthday money in, so you got a bit more, and it stayed the same for a while. Then you decided to buy something, so you spent a little bit of the money. Okay, so it stayed the same for a while. But then maybe you got a Saturday job, or maybe you did some odd jobs around the house. Okay, and at this point, the money went into your account and you saved up a lot more money. Okay, so at that point there, you had a lot of money. Then maybe you went back to school and you couldn't do the jobs around the house anymore. So it stayed the same. And then at that point, you suddenly decided you were going to buy something really expensive and you spent all of your money. So you're back down to 0. Now, on C, we're starting from a high point. Now, that might be quite relevant to the moment. If you think about people who have coronavirus, actually, one of the symptoms is supposedly a higher temperature. So maybe you could think about this. Maybe this is the point at which you started recording somebody, somebody's got a high temperature, and you record it, and it starts off that high, and then you notice it drops slightly. So you actually record a drop in the temperature. Then it stays the same for a little while, and then they start to feel a bit better, and it drops down for a bit. And then all of a sudden, it starts to get worse. So it gets slightly worse, and then eventually it drops down to a normal level. Now, remember, that would be 0 degrees, which is clearly not possible on temperature because that wouldn't be right. But you can label the legends as you wish to make it seem fit. So if you had this one as 37 degrees, which is a roughly normal temperature, up to I don't know, 39 degrees, which would be classed as a fever, then actually you can show the data in a different way. But this gives you a rough idea of how writing a story about a graph can work.